Thank you. My name is John Phillips. I've worked for King County Wastewater Treatment Division for 15 years. I've been working on climate change since about 2008 when I didn't show up to a staff meeting and was volunteered to work on climate change. At that time, I was working on it along with a GIS specialist who helped me do some of the first studies. Our 2008 report on vulnerable facilities was featured. I get actually referenced in both the IPC report this year and the National Climate Assessment. We picked sea level rise because it's what we had the best information on. So that's where we started, and it's kind of what we've been working on for the last 4 or 5 years. But to give you a broader picture, so I'm the only person speaking from King County, I want to give you the global picture of what King County does to address climate change. It is the #1 initiative of the Executive Constantine. It was a big initiative for Executive Ron Sims. Executive Ron Sims kind of kicked it off in 2007 with the Future Ain't What It Used to Be conference, and basically told us all to start thinking about climate change and what we could do about it. University of Washington Climate Impacts Group has been very helpful along the way, letting us know what they know about climate change and how we could adapt that to what we do in King County, providing regional services to Seattle and all the metropolitan area, as well as providing essential services like wastewater treatment. Some of the things we look at: flood planning and control, reclaimed water from our facilities, that's producing high quality water to use for irrigation, and of course sea level rise assessments. And the picture of our beautiful West Point treatment plant out near Discovery Park, obvious questions come up about that concerning sea level rise since it's right on Puget Sound, as well as the King County International Airport. So what are we doing for adaptive planning? We haven't changed this slide in a long time, but basically what we were directed to do is plan backwards, figure out when the impacts would happen and what we could do to address those impacts, as we did a lot of our programmatic planning essentially in wastewater, which was undergoing a large 50-year planning event, and updating that plan in 2007, and constantly asking the climate question to everything we do and the services we provide. And I like this quote from Executive Sims back in 2006, because this is a climate science conference. I figured I'd let you see a politician say, go listen to the scientists, not the politicians, unless the politician give you good policies to follow, and you can use those policies to do your work. The top policy is directly from the executive, basically saying we will be a leader in climate mitigation and adaptation, and also we will consider any climate change impacts in our programs, projects, and policies. The second quote up here comes exactly from the King County Council's ordinance back in 2010, and you'll notice the 2 dots there. I cut out the words that said by 2012, do all these things. Just thought I'd cut that out because I didn't want to answer questions, have you finished? In 2007, in cooperation with the Climate Impacts Group and ICLEI, King County produced a probably lightly read book on how to adapt to climate change. That outlined kind of what we took as our approach for publishing the first climate action plan in 2007 for King County, which was nice, black and white, fairly simple plan, updating it every 5 years. So 2012 was updated again, and we put color photographs in it. So that's the difference between 2007 and 2012. Not really, but we knew a lot more in 2012. After we had done the initial planning in 2007, I think the interest from the researchers and the scientists that were out there said, we've got a lot of data for you guys to sort through and figure out how that applies to regional services. It directs us to do all the things that I will talk about we're doing in wastewater. Listening to the scientists, of course, our main crop of information for wastewater treatment comes from the phone calls to Laura and Amy at the Climate Impacts Group. That's where I get most of my information, but also interacting with the regional Northwest consortiums, and also just kind of reading the IPC report just so we're familiar with it. But I would say that the idea of regional modeling and regional information far exceeds that which you can get from the global information. And from day one, we've been trying to make sure all of our data comes from the region versus trying to extrapolate anything from global data. So our first regional data came from sea level rise, yay, because that's something we wanted to work on. The et al. Study in 2008, Laura and Spencer Reeder were also authors. Spencer Reeder was working for Ecology at the time. Gave us just exactly what we needed. Here's sea level rise, here's the dates we expected. This was 2008. And our ability to actually apply that to our planning. We had it in feet and inches, which was good enough for us, and I'll talk about how we take that in a second. But we also, once we started talking about sea level rise, we were informed about something called storm surge. Storm surge was also another effect. And if you look at the amount of storm surge as compares to sea level rise, you'll notice that storm surge currently, as it's recorded, is pretty large, 3.2 feet. That's pretty significant when we're talking about inches within a wastewater facility. So both of these together, combine them up, and come up with a plan to say what will we do for capital projects. This particular table is in our documentation as guidance for our capital projects. So any capital project must consider climate change, must consider sea level rise as it does its planning process and in its design. And halfway through the show, I'll talk about how many different projects we've used this information on. What we did is we put the information together, we converted it to our own special datum, which is metro datum. It's just back in the 50s when they started planning the system, they didn't want to use negative numbers, so they just added 100 feet to everything. So we have these really screwy numbers, say 112 feet, 108 feet, but that's what our engineers use, so that's what we presented it in. And as you move to the right and to the bottom of this, your risk decreases the more you can address those elevations in your facility. And I will talk about some of our facilities and how much risk we have associated with them. But that's how we took the science. We compacted it into a nice little table. An engineer can look at it, look at their drawings and say, oops, I'm below that, I need to do something about it, or I'm pretty safe, I'm well above that. So what is the King County Regional Wastewater System? Well, we're the big guys. We provide wastewater treatment for 34 local agencies. So everybody sends their sewage to us. We currently serve about 1.4 million people, but I think we're at 1.5 million people now. And then by 2030, according to Puget Sound Regional Council, we'll be serving about 2.4 million people. We operate both in Snohomish, King, and in Pierce County, mostly the metropolitan area, as you would call it. We have 47 pump stations that we're responsible for, 25 regulator stations, which are small facilities that have gates and weirs that control the flow to bigger and smaller pipes. We have 391 miles of pipe. On average, we treat about 200 million gallons per day of sewage. And like I said earlier, 34 local jurisdictions depend on us for wastewater treatment and, of course, pay us for it, so they expect good service. So we talked about on-site flooding. When we talked about on-site flooding, we wanted to look just generally at what facilities will fall underwater based on LIDAR information. That was a study we did in 2008. When we completed that, we came up with a nice table, a nice table to show what facilities were vulnerable, but really looking at the surface elevation of the facility, what would be underwater. I use this picture because this is Alki Beach on December 17th, 2012 during the King Tide event, and you can't see the seawall anymore. And a lot of our pump stations are on the other side of that seawall. This was a summary of our first study in 2008, and again, just always moving to the right and to the bottom, your level of risk goes up. One of the things we were asked once we presented this information to our management was, what's the worst case scenario? And we said, well, I don't know. And again, talking to the climate impacts group, what's the worst case scenario? Very controversial at the time was rapid ice sheet melt, and they said there'd be an elevation. You could see elevations in 20 feet. They didn't give us the 2 centuries part, but we thought 20 feet was good. So if we threw 20 feet into our analysis, we pretty much put all of our facilities underwater, so that was a good worst case scenario to use. But in general, with storm surge and with sea level rise moving across the 2050, 2100 scenario, you can see the number of facilities. The yellow is 8. The more pastel the color, the less facilities are being impacted by sea level rise. Now this is just surface flooding. At the same time, we started looking at the amount of salt water we had in our sewage system. So during our King Tide events and during the courses of the year, we had Daryl, pictured there on the left. Yep, on the left. Had Daryl out there actually measuring conductivity within the wastewater stream. Wastewater by itself has no conductivity, it should be 0. So what he did is he went out with these small meters, he'd measure conductivity, and he'd get a sense of how much salt water we were actually transporting to West Point, especially during the King Tide events when we expected the most inflow of salt water. I've got some pictures to prove it. He'd open a manhole, take a sample, stick his meter in there, and a lot of times that water was actually clear. And sorry, it's after lunch, but sewage is not clear, it's brown in color or gray in color. So when he'd see clear water, he was pretty much measuring salt water in our pipes. Salt water and concrete and metal do not mix. It increases the amount of corrosion, and we've estimated our cost for fixing corrosion ahead of schedule. In other words, life cycles less than 50 years is somewhere between $4.1 and $7.9 million. And these are pipes and equipment that are at the West Point treatment plant and out in our conveyance facility, gates and other structures that are made of metal. Concrete also corrodes under high corrosion conditions, and that's also fairly spendy to fix. And a lot of these pipes are big. Our biggest pipe is 14 feet. So this was about the same event, December of 2012, when we had the large king tide event. This is not supposed to be wet. That's a walkway where the water's coming up through it. Underneath there is the wet well. That's where the sewage kind of sits before the pumps can catch up and move it. And this was just water coming up above that walking grate. This is a little bit better image of what we're talking about. Normally, there is no water going over that kind of wall you see there. That is clean water coming in from Puget Sound, going into our wet well and being pumped to our treatment plant. That was another king tide event. This was a pump station out in West Seattle. Some of the pictures I showed earlier of West Seattle were taken on the same day when the waves and stuff were crashing over the seawall. And a few houses actually got flooded along the way too. So major concern was we're pumping a lot of seawater. Our vulnerable facilities of flooding didn't show us this many facilities being impacted. So we started looking at fixing the ones we knew about. This is the fix. This is about $20,000, what we call a flap gate. Basically, it's a spring-loaded gate. Water can push it open to go out. If the tide comes up against it, it stays shut. Took about 2 days to install. But understanding that surface flooding was the only issue we were going to be dealing with. The hydraulic system, as you can see in this image here, is fairly complicated. There's pipes, there's pumps, and there's gates, and there's weirs to deal with. And all of those had elevations associated with them. Going back to our little table with all those elevations, these are the things the engineers needed to consider. So we started taking an evaluation and inventorying all the elevations within all those 47 pump stations and 25 regulator stations and going, where are the elevations of these, and are there any backflow preventers, flap gates, tide gates to protect it from sea level rise? And we just did basically an assessment. And since this is a science conference, here's your graph. These are all the facilities that we found we looked at that are subject to tidal influence. Going across the graph, anything in green had a flap gate. If it's green and blue, we are currently putting flap gates in, and if it's blue, it doesn't have one. And then we just put each sea level rise scenario with storm surge and just said, okay, which ones will have saltwater intrusion under certain sea level rise scenarios, and which ones will actually kind of be submerged. The hydraulic systems, that means all the pipes underwater, the outfalls, will be submerged. And slowly but surely, we are addressing all the issues with the ability of water to come in under those scenarios by installing flap gates or redoing the facilities. The Barton pump station down near the Fauntleroy Ferry dock, that was the picture of the flap gate that I showed you earlier. And then the Murray pump station down by Lowman Beach, if you live in that neighborhood, you know we're doing a giant construction project. That facility will be addressed. The nice picture I showed you of all the water coming into the facility, that's the 63rd Avenue, which is also in West Seattle. That's being addressed with a new flap gate, although that one's fairly complicated as we have to go out into the tidal zone to actually get to the point where we want to put the flap gate. So the other thing, I talked about the big treatment plant. West Point is the largest treatment plant in the state of Washington. It serves about 700,000 people. It's not a cheap facility. It probably has about $1 billion investment in it, so we thought, well, why not check it out for sea level rise? But the first thing we did is we talked to our operating staff about sea level rise, and they said, hey, you know what, we use more energy sometimes when the tides get high, and we couldn't quite put our finger on that one. So we met with some of the operators and started looking at the data about how much energy we use, and actually found that some of the more senior operators actually use the tides to drain out the wet well after the water's been treated, and some people kept pumping it. So that's why we're seeing energy uses. So the tide didn't necessarily influence how much energy we used to pump. It was actually something about how the system was operated. So working directly with the operations staff and the more senior operators, we helped them write procedures and do training to reduce the need of pumping as the tide moved in and out. So when we thought we were actually going to see something where we were having to increase our pumping when the tide was high, it actually turned out it was just a matter of who operated the treatment plant, and the tide had no effect on how much energy we used. So problem solved. But the facility from flooding, again, using LiDAR data, but also grabbing the survey data. I maintain about $10,000 a year to send surveyors out just to kind of do elevations for us. And we went ahead and looked at West Point. The facility, if you've been to Discovery Park and hiked along the beach, is behind a fairly large bermed wall. The shortest wall is at about, I'm sorry to use metro elevations, that's what we're used to. It's about I'm going to say 120 feet in our metro elevation, so take 96 feet off of that, and that gives you what the NAV D88 elevation is. So we felt like the facility was pretty well protected. We talked to our operators about times during king tides, and what they pointed out was, well, yeah, the trails flood, but nothing really comes into the treatment plant. So this answered the question because I have people from the city of Seattle here. They did a really great press conference back in 2012 or something like that, and immediately said, our wastewater treatment plants are going to be underwater. And we went, oh boy, that's news to us. So we got good motivation to go out and do this quick study to find out if West Point Treatment Plant would be underwater. And while it was not done on purpose, the facility being armored the way it was protected it from sea level rise. And I'm not going to say that anybody was thinking about that in the 80s when they upgraded the treatment plant. It was done for more of an aesthetic purpose, that's landscaping, so people wouldn't see the treatment plant when they walked on the beach. But, you know, served a dual purpose. We just completed a vulnerability from actual flooding, so we were actually asked to look at flooding from creeks, rivers, and lakes. This was done in GIS, and there's a poster going to be presented on that this afternoon in Meany Hall. We identified key structures that were within floodplains. Floodplains are fairly nefarious data. Everybody has their own version of it, and not all of it's 100% correct. But we used that data. We looked at the floodplains and looked where our facilities were within that floodplain. If a facility was in a floodplain, we considered it vulnerable. We had 6 facilities out of the 6,000 that poor Crystal looked at. Is Crystal in the room? There she is. Yeah, we had her working for a year or so. Looking at every single, I was including manholes, all that stuff. We said, yes, Crystal, you have to look at that. So we came up with actually 6 facilities that were major facilities, pump stations, treatment plants. And we're going to spend the next couple of years actually going in and doing the more detailed analysis with survey data. On a long-term look, temperature, as we heard about this morning from Amy Snover, you know, we'll keep looking at it. We did look at sewage temperature in a very hot day in 2009 that reached 103 degrees, and the sewage temperature wasn't the warmest it was that year. It was actually warmer another day, and we found out that Red Hook Brewery discharged some pretty warm water to us that day. So finding out what really influences temperature of sewage was kind of interesting. Precipitation, same thing. Our hydraulic modeling is not as accurate as the climate models, so the factor of safety we put into the design of our facilities is greater from that uncertainty than the uncertainty around precipitation. I just had to explain that to the Regional Water Quality Committee last week. They didn't quite buy it, and we were accused of not believing in climate change. And we do. We believe in climate change. But we're not putting precipitation as a major contributor to the size of our facilities. What we do think is more cost-effective is actually have a project of adaptive management where we reduce inflow and infiltration from local utilities and stormwater from local utilities. In that way, reserving the capacity for future population growth. Much cheaper. Can't leave this presentation without acknowledging the work of a lot of people that have helped me over the years do this work. Sean O'Neill and Crystal Murphy have been been doing the majority of the work, and they're both GIS analysts. Using Esri ArcView equipment to do this. I'm open for questions. Thank you. Oh, there's one, there's 2. In the city of Seattle. Does the stormwater mingle with wastewater in our system? And that's yes. In the city of Seattle, we have what's kind of combined sewer overflow. All of the facilities we had analyzed in our sea level rise are all in the combined system. So they all have extra capacity for stormwater. Gentlemen.
Your last item on one of the last slides talked about adaptive management being the most effective way to do that, to deal with these things. How do you sell that to higher level officials when often adaptive management, as you explain what you're trying to do, means we have to learn about this. We don't know what we're doing yet.
They like that answer because we can say we spend the money in the future versus now. We call it the most cost-effective solution because the solutions to it the cost can be spread over a much greater area. And also, like I said, a lot of times it's working with local agencies to fix inflow and infiltration or to fix stormwater coming into the system. So it's fairly easy sell, especially if you say we don't need to spend the money in the next 10 years. but we can reserve that money for later or be ready to use that money later. And actually, ecology and EPA both buy off on that as are addressing climate change. They're more concerned about sea level rise when we submit procedures to them. They understand what we're trying to do with adaptive management. We don't know the answer quite yet, but we'll keep an eye on everything.
How did you decide, of the facilities that were affected by sea level rise, how did you decide how to prioritize which ones to go after first?
Well, basically, we took the ones that were easiest to fix, and then we're working from there. So that's basically, and then it's also kind of an opportunity. There's an opportunity to fix the ones that are undergoing major capital projects where the cost of fixing it is far less than the cost of the project that's going on. The 63rd Avenue, because of the amount of wastewater that was coming in, became a high priority because it was 2-3 million gallons per day. That would, not every day, but on those events, so that was a priority. And then we just go out and we monitor. We have teams, 3 or 4 teams of 2 that go out during king tides and just observe and see what's going on. Because some of these facilities, they should have water coming in, but for some reason they don't. So until we see water come in, we don't really go out and fix it. So, yes.
Do you know if there's been any monitoring of like methane generated at the wastewater plants and any plans to capture that?
The question was about methane at the wastewater treatment plant. I could be really coy and say, that's a mitigation question. Yes, we do produce methane at the treatment plants. We harness as much of that we can to offset our energy needs. So both treatment plants produce electricity or energy from methane. We do greenhouse gas calculations every year. Methane is part of that. Most of the folks at the plant can take how much methane we should generate, subtract that from how much we use, and we get a sense of how much greenhouse gases we export from methane, methane being a much stronger greenhouse gas. But we still don't really get up that high. We didn't even trigger EPA or ecology's requirement to report. So it's not a lot because we want to use it. It's valuable, as you heard earlier this morning.
All right, thanks, John. I think we'll move on to our next speaker.